To find the sum of the angle measures of a quadrilateral, we can draw a line that divides a quadrilateral into two triangles. And because the sum of the angle measures of a triangle is 180 degrees, the sum of the angle measures of a quadrilateral would be 180 plus 180, or 360. That is, a quadrilateral always have 360 degrees measure for the sum of the interior angles. Let's repeat this for the angle measures of a pentagon and hexagon. So for pentagon, we can draw, looks like we can break this up into three triangles. So one triangle is 180 degrees, one is 180, one is 180. 3 times 180 is 540 degrees. So the sum of the angles of a pentagon is 540. A hexagon has 6 sides, and we can break this up into 6 triangles. So 180, 180, 180, and 180. Well, 180 plus 180 is 360. 360 plus 360 is 720. So 4 times 180 is 720 degrees. So notice a triangle is 1 times 180, and it has 3 sides. A quadrilateral has 4 sides, and we go 2 times 180. A pentagon has 5 sides, and we do 3 times 180. A hexagon has 6 sides, and we go 4 times 180. So that would suggest that for an n-gon has the number of sides in, we subtract 2 and multiply by 180. And that is exactly what happens. So an interior angle, or a vertex angle, is formed by a vertex and the 2 sides that have a vertex at the end point. So they're the corners of your polygon. The sum of the measures of the interior angles of any n-gon is going to be 180 degrees times n minus 2. And that's because no matter what the n-gon is, we can break it into n minus 2 triangles. And then n minus 2 times 180. So find the measures of x, y, and z and the interior angles of the pentagon penta, P-E-N-T-A. Well, there are 5 angles. So the sum has got to be 180 times 3, which is 540 degrees. So if I add up those interior angles, there's a 3x, an 8x, an 8x, an 8x, and a 3x. So 3x plus 8x plus 8x plus 8x plus 3x has to equal to 540. As 24 plus 6 is 30x equal to 540. Divide by 30, and we'll have x is equal to 18. All right, and so the interior angles are either 3 times x or 8 times x. The 3x's are going to be 18 times 3, so those are 54 degrees. That'd be that lower left corner and the lower right corner of 54 degrees. 8x would be 18 times 3. So 18 times 2 is 36, times 2 is 72, times 2 is 144. So these angles on the inside are 144 degrees. As for y and z, notice that the 3x and the y are supplementary in terms that they add up to 180. So I know that y plus 54 are supplementary, so those add up to 180. And that tells me that y has got to be 126 degrees. And likewise, the z and the 8x are also supplementary. So z plus 144 degrees is equal to 180. That means z would have to have been 36 degrees.